little bit of a hiccup there. Is it live or not?
It's live.
It is?
You're just talking to one person.
Am I talking to you?
No.
Bum, bum. See comments, but I don't know if it's... Oh, yeah, okay. Randy's here. Derek's here. Cool. So I was going to do this as a recording, but I just figured I would go ahead and do a live session because I haven't done one in a while. See what you guys are up to. But I had a bunch of questions from a couple of people about boost control with Holley. So we touched on it in a couple of the other videos, or two of the other videos that we've done, but I didn't really concentrate very much on it. So I wanted to do a basic video of basic boost control methods, like the straightforward options that you have with Holley, and have that be the only thing that the video is about. But if you guys have any questions while I'm at it, by all means, ask them, and might do another video later, or if there's time, I can answer them now. So hopefully you guys can see the screen here. Get
live stream offline.
one of these open. I don't. Oh, now it says. Took a while for it to catch up. You're able to see it on yours though?
I don't know, there's an ad playing.
Oh. Yeah. Alright. So let's see here. What are these? I guess it doesn't really matter. Blah, blah, blah. Okay. Actually, let's see. So depending on what you start with, what calibration that you start with, that option may not even be up there. So if it's not up there, I think everybody that asked about this stuff was already using boost control, but they were using different methods that weren't working out for them. So, but if you are that far back, you can go here. Dun, dun, dun. Let's see, we got individual configuration library, and then it has all of those tabs that are up there. So you select boost. So there's a couple of options here. We'll do the single stuff first because I think it honestly satisfies most people's setups. I guess it's kind of tricky using the DOM reference. I mean, it's not really, but like I think it does throw a lot of people off. It confuses a lot of people, so they end up going for. What's up, Anthony? They end up going for a more basic setup, and I don't think they realize that they don't understand that portion of it either. So when you first come in here, it's going to ask you, wastegate type. So single or dual. The dual is going to be dome pressure control. I think that's the only option that they actually give you. So anyway, the first solution that we're going to do, you can just select single port. Or actually, you know what? Let's go ahead and do dual port. We'll do dome control stuff first. Okay, so this is Holley's preferred method of boost control. I don't really like the dome control thing, but I get how it works. It's just as usable as using the map as reference. But so then it's going to ask you your solenoid configuration. Single Holley 3-port, or these are just types of 3 ports. I don't actually know whether the Humphrey is normally closed or normally open. Maybe that's the only reason why they actually show it as a difference. But the Holley 3-port is a Mac solenoid. It's a Mac 3-port, same as pretty much every other rebranded solenoid that people sell. Or the dual Holley solenoid, which is 2 3-port solenoids joined the way they want you to do it, so that one is like a bleed and one is an add. It's not my favorite setup, especially because if you can do anything simpler, I always prefer to do it simpler. So instead of having two 3-ports, I'd rather have one 4-port, but we can get into that later. And then there's a custom where you can say whatever the hell you want. But uh, let's just use just a single Holley 3-port, for example. Now, the downsides to using a single Holley 3-port, regardless of whether you're doing dome pressure or uh, controlling it by map, and see that's your next option, whether you want to do dome pressure only, or you want to do just raw duty cycle, or whether you want to do a map based setup. So the 3-port is going to limit you. You're only going to be able to do a certain multiple of hey Jake, what's going on, man? Yeah, live. I know. I haven't done this in a while, so I'm a little weirded out. And then you got her foot in the background. Um, so anyway, getting back to this, where are we at? Map and dome pressure. So we'll do dome pressure only, since this is, like I said, kind of Holley's thing. They want you to use the dome pressure method. And all that's doing is basically saying, instead of your targets being how much pressure you want inside your intake manifold, it's saying how much pressure do you want on the top of the gate. So if you have it, theoretically, if everything is working perfectly and you have a 5-pound spring and you request 5 psi on the dome, that solenoid or those solenoids, regardless, or whatever your setup may be, is going to be pulsing how they need to pulse in order to provide 5 psi to the top of the wastegate, which should yield 10 psi in your intake manifold. I guess the one positive thing is it's an indication of whether you've got an issue or not. So if you are targeting 5, but it's always going higher than that, you may have an exhaust pressure issue or a wastegate priority issue or something like that. If it's spot on, your system's working exactly how it's supposed to be, which is nice. Okay, so then you would go into dome control setup, and then you have to tell it what solenoid, what your source is for your solenoid. So that solenoid is going to be sampling from something. It's going to be pulsing, regulating the amount of air that goes to the top of your wastegate from something. So people that use CO2, are going to have a fixed. That would be a fixed area. Dirt floor fab with the super chat. Been missing. Sorry, I got my camera right in front of the screen. Been missing the weekly live streams. How you been? Loving the Mexico footage. Yeah, I'm glad everybody liked that. I haven't really done a long street video in a while. I've been good, man. Just busy trying to get the house sold and eventually moving down to Texas. So Tony's been working her ass off trying to get the house ready and everything. And
Wait for my car to be done.
yeah, because she knows when we go down to Texas, we'll finish her car. And yeah, she doesn't realize we both want the car to be done quite a bit, but trying to be smart about it. Probably her more, at least a little bit more.
A lot bit more.
Okay, so these are going to be your methods where Holley is going to, it needs to know so that it can modulate these solenoids. You can change the PID terms, so you can change how the reaction is to how far off you are from your target boost. But this is going to basically help the ECU understand what your setup is like. So if you have a fixed duty cycle, you can actually come in here and give it what is the fixed pressure that you're going to be sampling from. So that solenoid, if you have your CO2 setup, for example, you've got a reservoir of CO2 with a regulator, and whatever you regulate that CO2 at, or if you have a compressor tank back there, which a lot of people do, you're going to also have a regulator. How much is the solenoid able to sample from? So this may be 60 psi, 50 psi, whatever you do. Just it wants to know. That way it can tell a tiny duty cycle change when it's 100 psi reservoir as opposed to a 20 psi reservoir. That's going to make a giant difference between the two. So that's there to help with that. Compressor is going to be if your reservoir is the turbo, or whatever means of pressure that you're going to be using. So in that scenario, it knows that it's going to be fluctuating based on the boost that you're building. So it gets kind of weird because you're trying to use this to modulate boost, but it's using the boost that you have to actually control. And it sounds complicated, but that's actually a normal thing. That's usually what we do. I think there's fewer people that are using CO2 or some sort of compressor tank to regulate boost. And I haven't had a problem regulating boost in tons of different types of cars. Big motor, small motor stuff, doesn't really matter. Using what would be considered by Holley as compressor method. Measured, I'm gonna be honest with you, I have no idea. I've never used it. Let's see. Oh, we got nothing. Interesting. Oh, okay, I bet you I know what this. So this is maybe if your reservoir fluctuates, so you can set up a sensor to measure that pressure source and then put it in here. So it'll be similar to a fixed setup, except your reservoir that you're pulling from has to be measured by a sensor that you put in there. And I'm assuming once you actually set it up and configure it, it would be selectable in here. I'll be honest with you, I'm not sure. So far, I haven't really had to mess with these terms very much. If you run into a point or into a scenario where you're constantly overshooting or undershooting, these are going to be the terms that you might have to play with to get boost control to be tamed down a little bit. Or if it's too slow coming up, usually it's a matter of overshooting. And these terms can help out quite a bit with that. So can this. So this is a really easy thing to get. If you do a pull, at a decent amount of boost, you don't want it to be at gate. That's not really going to give you a good accurate thing. Don't necessarily have to do it at max boost either. You just need to take a sample from your log and figure out what the rate at which your setup can build boost is. So, for example, mine I think is like 18 psi per second or something like that. So when the turbo starts to stand up, you get a rough idea of how quickly it can stand up. That's going to help. Again, this is all trying to help the system understand, because this is a closed loop system. So you're trying to prepare the system to know what's going to happen when it makes little duty cycle changes. So that helps out quite a bit with that. These terms, you can get in trouble with these really, really easily. Make relatively small changes, or go and just Google PID loop, and it'll explain what each of these terms is meant for. So I guess the further away you are from the target, the computer is going to make a drastic change. And the closer you get to that target, these terms help with making sure that that value that it took, so let's say it ramps up to 100% because you're way low on boost, these help with making sure that it's a drastic change at first, and as you get closer to your target, it's going to neck it down so that you don't overshoot. And that's what I'm saying. So if you've got a boost curve that looks like this, up and down over and under your target, you might need to mess with these. There could be some other reasons why it's doing that, but if everything is working normal, then these terms might just be a little bit out of whack. Okay, so once you have that, so that's compressor, then you come in here, and this is pretty self-explanatory. You can change what your scale, or what you actually control boost by. And when you have it set up like this, it's boost per time. So it's literally whatever you base the trigger to be off of. So like trans brake, as soon as you release trans brake, this table is going to start ticking away. So right now it's like scaled all the way up to 15 seconds. So if you had it, 10 pounds or something at 15 seconds, which would be weird, all the way down to 0 there, and then fill row values. There's your boost curve. It's going to be increasing, and you can go back in your log. The really nice thing is if you go and do a pull, and then you look at your log and you scroll over a certain point, let's say it starts spinning at a certain point, the cursor will actually be right where it's sampling from, so that you can make sure that you make adjustments to the right cell. If you're like, oh, that was a couple of seconds out, and you come in here and you're like, I think it was about 5 seconds. Well, that can screw you if it's actually at 6 seconds, and you're making changes, hitting your head up against the wall, trying to figure out why it wasn't working because you're actually sampling from up here. So, okay, that is that. Boost Builder. It's not available on the Terminator X stuff, but in HP and Dominator, it's somewhat useful, I guess. I usually don't use it. You can come in here and fix timing. So if you want this to always be at 0 while you're on the trans brake, so that it's like, really violent, or you want to do negative timing, or if it's the other way around, if you have for example, a friend of ours has a really hard time getting up on his converter, and he has to actually add a decent amount of timing because he can't retard it until he starts making any kind of boost. The converter is so tight that if he pulls any kind of timing, it's just going to pull the motor down. It's not even going to get to the launch control RPM. So anyway, you can make that fixed to where it's always activated, or it's always at that locked timing. I don't necessarily like to do that. I like to use an advanced table to retard timing based on something else, whether it's RPM or load or whatever. But you can do the same thing with fixed fuel or nitrous activation, which is nice for the guys that have to use nitrous to get up there because they have super tight converter or something. Yeah, you can enable that on trans brake launch so that when you go into your pin map, everything that is related to trans brake launch stuff, this becomes one of those items. So you got that one input that says trans brake launch enable, and you can assign a bunch of functions to it. So you can do it a couple of different ways. Let's see. Oops, there we go. Or no, let's look at the other thing. So come up here. This is something that you can also do. So launch target. As it sits right now, because of what we have selected, this is a dome pressure setup. So we're targeting how much boost while the trans brake is enabled right here. So this is saying it wants 5 psi. Now that's the requested target. The duty cycle that it takes to actually get 5 psi, in this case on the dome, is going to be drastically different than the duty cycle that it takes to yield that same 5 psi as you're running down the track. The load, the RPM, it's different. So a lot of times, like if you're doing raw duty cycle, where you've selected it to be just raw duty cycle, you're telling the solenoid what duty to do at any point in time. So then this window also becomes a duty cycle. Let's show you real quick. Single 3-port is fine. What are we doing here? Let's do map. Single port. Open loop duty cycle. Okay. So for example, when you're in open loop doing duty cycle only, this value, let's say to get, let's say you're launching at 3600 RPM, and you might need 60% duty cycle to get like 4 psi out of it. So when you're on the trans brake, your solenoid is clicking away at 60% duty cycle to try to help the boost to come up. You also may have some timing being retarded to help it build boost as well, but the duty cycle that it shows right here. And the reason why they have that to be a separate duty cycle that you can do is, one, to help you target something specific on launch control. But the duty, let's say you want 5 psi all the way down the run, you're not going to be at 60% duty cycle all the way down the run. I can almost guarantee you that. So if you want to launch with 5 psi and do 5 psi all the way down the track, this duty cycle is not going to be the same. And so when you're doing a target-based setup, you can see that. You'll be able to see the drastic differences in duty cycle between launch control versus going down the track. Big Booty Judy, what's up? Just going over boost control basics. Had a couple of people ask about it, so I figure we'd just have a little live session and go through some stuff. So that's kind of a big one. One of the guys that was asking me questions was under the impression that that would be the same. So if you have 60% in there and it yields 5 psi on launch control, you come in here and be able to put 60, percent all the way across the board, and you would get that same boost all the way across. It's not going to be the case. It's going to jack up like crazy as soon as you let go of the button, basically. More than likely. I can't think of a scenario where it would be the same. So then let's see. The other method I wanted to show you is the map control. So this is the way that I have my boost control set up. I did it on open loop duty cycle for the longest time because I was just kind of used to that using other management systems. But when I realized how good Holley was with their feedback loops, I decided to give this a try. Now, I'm kind of fooling the system a little bit. I'm telling it single port wastegate type, and the solenoid configuration is a single Holley 3-port. I'm using a 4-port. It honestly doesn't matter. It's going to operate that 3-port the same way it would operate the 4-port. As long as I have my base table pretty close, it's going to be able to fill in the gaps really easily. You can't lean on it completely. It's not that good of a system where you can just not have any base table and just say, I want 15 psi, and it'll just figure it out completely. It's almost that good, but it's really not meant for that. So what we do is I come in here. So this will work whether you're doing a 3-port or a 4-port solenoid. Either one will work. And let's say, we could just leave that boost per time, I guess. And so now what I'm telling it is I want to regulate the amount of boost that goes into my motor using the map sensor as my pressure reference, and the manifold as my pressure source. So what we do, this is now available. So before it was dome control setup was available. Now I have to do this completely different table because I want to use map control. So this looks more complicated than it actually is. You don't really, I mean, if you want to see what your curve is, these tables down here do come in handy. But really what we're doing, you can make this very basic to start off with, and it will work pretty darn good. So they have, different values up here. They got a curve and whatnot. Honestly, to get started, you can set your target. So you can come in here. This is boost per time now, and it's based on target. Oh, am I covering a bunch of shit? My bad, guys. Hang on one second. Good call. Thank you for bringing that up. Why didn't somebody tell me that earlier? All right. Thanks, Chris. Sorry about that. All right. Now that you can actually see what I'm doing. Okay, so let's say basically what this table is, it's a reference for the computer. So when I tell it I want it to do 7 psi at any time or RPM or whatever I have the axis as, it's going to first look up this table. So what duty cycle will yield 7 psi? Because I want 7 psi to happen, and it's going to come in here and it's going to say, all right, for 7 psi, and you would go out and test that. So you can go in raw duty cycle and set it at 20% all the way across the board. That's one way to do it. You can do raw duty cycle and figure out, and I'll start over. I don't know. I'm not starting completely over. You guys get the idea so far. So you can either set it to raw duty cycle and just try like 10% increments until you get to your full boost. And just make note of that and then come in and populate this table. Or you can take a stab at it basically, and you can see how much Holley is going to be compensating. So if you say I want 7 psi, and your gate setup is able to do like 2 psi or something like that. Well, this is doing 0% duty cycle for the majority of this table to get 7 psi. Chances are it's going to try to do 2 psi, but only for a little while. Holley's going to realize that you want 7 psi, and it's going to start increasing the duty cycle, because while you're doing the pull and you're at 2 psi, it's going to be like, well, that's not 7, so I'm going to increase duty cycle until I start seeing 7. And so you may be able to get the value that you need doing feedback. That's how I did it in the truck because I made a random guess at this table and it was relatively close. But when you're just completely shooting in the dark, maybe you want to go to setting up on raw duty cycle and going up in 10% increments and then coming in and populating this table. But anyway, basically you figure out what duty cycle yields 7 pounds, and let's say it's 15%. I just do it all the way across the board. You can start getting more specific later on and building a curve, because the percentage at a lower RPM to yield that same boost is obviously going to be different than the percentage that it's going to take at a high RPM. So theoretically, this number will be different, but will it get you going? Absolutely. So then you come in here and let's say for 10 PSI, it's, 20% duty cycle. And then just to make things quicker, you can fill column values so that it fills in that nice progression there. And then let's say the next duty cycle that you do goes up to 15 PSI, and that is, 30% duty cycle. Pay no attention to these numbers. They will not work for your setup, or at least they might. They probably won't work for your setup. This is just random values we're talking about here. And then let's see. Oh, this one goes up to 15.6. Okay, so then we say this is like, Jesus, 45. Okay, well, assuming that your setup is pretty much maxed out at 16%, let's say that is 45%. Column values again. Okay, so there is your base table. And like I said before, this is what this is going to do. So at any point in this table, let's say, and this is boost per time, so let's say it's going to be a progression. You're going all the way up to 16 psi by the end of the run, which let's make believe is 15 seconds. Seems kind of ridiculous. So if you're sampling from the 6-second cell and it's targeting 10.6 psi, the computer is initially going to go to this table and say, all right, I'm at this RPM, and my target right now from the target table, let's say I'm at 5,000 RPM, and I'm targeting, about 10, in between 10 and 11 psi. It's going to initially assume that it's going to have to use around 21% duty cycle. Immediately, literally immediately. I mean, it'll be hard to even find that point in your log, because Holley is going to be immediately changing duty cycle to yield that. So if you're not at, 10.6 psi exactly, Holley is going to be trimming the duty cycle to try to yield that. Can we get a cat ET for the next? I have no access to anything cat related. What you doing?
Nothing.
Oh, nothing. Hanging out. Okay, so but this is what this base table does. It gets you in the ballpark so that the computer doesn't sit there and have to swing like 50% to try to yield the appropriate, or to try to run the appropriate duty cycle to yield the boost that you're targeting. So this is very important in having a nice, smooth map control setup, boost control. Derek says, hey.
Hi.
Hey, Tanya. That's delayed, so.
Oh.
Yeah. The active one is here, but then you can't see comments.
Oh, well, I don't need to see it. Go back.
Oh, okay. All right. Anyway. Blah, 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 blah. Yeah. I don't even actually know what I accidentally selected. Okay. So anyway. So yeah, one of the guys that was asking about boost control stuff, this is the table that I'm talking about. This is what you're going to have to populate. And so you're going to have to go out and do a little bit of testing to figure out what duty cycle yields what boost. Once you get that, and obviously you can scale this. So if you need to go all the way up to like 30 pounds or something like that, then just put that in there, scale it, and then redo your duty cycles. So, but yeah. Oh, Tony wants to go to 100.00, oddly enough. Oh wow. It did it. Anyway, okay, so that's going to be that's necessary to start using this. I mean, I tried it before I even populated that table, and it actually worked pretty good. But it made it much smoother. Hit its targets right away, held the targets. It was really nice. Really need to just bite the bullet and buy an HP or Terminator X. Dude, the Terminator X is damn good for the money, and Matt Happel has been using it quite a bit and fiddling with it. He's got some pretty good workarounds for the shortcomings of the Terminator X. HP can't go wrong, uh, and a Dominator is for fancy people, so we can't afford that.
Woo.
All the inputs and outputs. Let's see. Okay, so same. It uses all of the same functions. So launch target. Since we're back to a feedback related thing, um, you know, you just type in whatever PSI you want it to yield. Now, there's one thing to make sure. A lot of people make this mistake. The 10 PSI target when you're on launch control. You have to be careful with what that does to when you let go of the button. It doesn't reset the feedback on the duty cycle. So if you don't have a bunch of timing pulled, if your car needs it, I mean, you may have a big old motor and it makes 10 psi pretty much no problem, and it's just using the solenoid to regulate yourself at 10 psi. But if you have to pull a ton of timing to try to make it come up quickly, if you pull too little, and so you're just sitting there on the launch control and it's taking a long time to build boost, this, because it's trying to go for 10 psi, is going to be causing the ECU to go up in duty cycle like crazy. So let's say for 10 psi when you're on launch control and you have like 18 degrees retarded, you know, you sit right around 30% duty cycle or something like that. But then if you don't have that timing pulled to help it build that boost, it takes a long time to do that, and duty cycle starts climbing and climbing and climbing, and it just pegs out at 100%. It's because it's trying to help you get to your 10 psi target. As soon as you let go of that button, it's still going to be at 100% duty cycle. So regardless of what you have in here, let's say you only have 7 psi selected here, and it only takes 20% duty cycle to yield 7 psi on your setup, it's still at 100% duty cycle coming off of the trans brake, and it's gonna, as fast as Holley is, it's gonna take a little bit of time for that duty cycle to chop out. And so what you're gonna end up probably doing is going well over 7 psi for a brief moment before it settles back down. Then it's probably gonna undershoot a little bit, and then it's gonna level out and come back. But it can ruin a run. So sometimes when you're struggling with the boost control, you really, especially with the target-based stuff, you still have to be cognizant of what the duty cycle is actually doing. So just be aware of that. If you want this 10 psi target to happen, quickly, you might have to use an advanced table to retard some timing so that it can get up there quick, so that duty cycle doesn't have to do anything crazy to get it there. I hope Hayden got a notification for this live stream. Yeah. Well, and it's boost control method. So his was just he was under the impression he could put a lot of boost in at an early time. But yeah, he's got it going now. Let's see, what else can we go over? Does anybody have any specific questions about this stuff? Those are really the two things that I wanted to show, was the map control setup. I think a lot of people don't use this because it pops up this table, and people don't know what the hell to do with it. And they force a situation that they don't necessarily need to be in, because Holley's recommended method of boost control is, the dual 3-port solenoids and the dome pressure sensors. It's really not necessary. You can control boost really well by using the value from your map sensor, populating this table, and using a 4-port solenoid or a 3-port solenoid. And it really depends. I like using a 4-port because we occasionally do some stuff on some really slick surfaces, so I need to be able to turn the power way down. I want to be able to go down to 4 psi, maybe even a little bit lower, but I also want to be able to max out my turbo setup. So that's asking more than a 3-port solenoid can provide. A 4-port solenoid is going to be taking the pressure away from the bottom of the gate, which would be aiding the spring to open that gate, and adding it to the top of the gate. So 100% will be everything to the top of the gate. that will max out any turbo setup. You want to know what your turbo setup will run, regardless, or well, taking into account that exhaust pressure. If exhaust pressure is too high, then it's obviously going to give you a false signal. But let's say you have a perfectly efficient setup. Put one single boost line to the top of the gate. It's going to do everything that it can do until exhaust pressure pushes the gate open. Let's see. Dartfloor Fab says, I'm not buying a boost controller this year. Plan on upgrading this winter. Don't need to throw money at a standalone controller. Yeah, no, definitely not. Especially if you're planning on, getting into a Holley or something. Do you lose an output by having electric fans? ECU relay control. Yeah, unfortunately, it is one of your outputs. Are you raising your hand for a question?
Yeah.
Oh, what do you got?
When do we get to apply boost to my car?
Oh, when it's done. You better be an expert by the time we get to that point.
Well.
Hayden was trying to pull a dark helmet. Dark helmet? Is that a Spaceballs reference? I'm not actually sure. Please let me know if that is. I thought it was Darth helmet. Is it dark helmet? I guess that would make sense. Okay, good. All right. I was making sure I was getting that reference. Let's see, what else? What do people do? So all of these, these are a bunch of safety cuts. That's no fun. Turn those off. You can set up a bunch of these to, at certain boost levels, you can tell it to do a certain function. So if you are at PSIG now, and also keep in mind if you're somebody who's at altitude versus somebody who is at sea level, 25 PSIG is going to be different than if you're used to seeing KPA. So you can tell it to either revert to wastegate, which basically just shuts the solenoid down. You'll be at 0% duty cycle as soon as you hit that boost. You'll still be able to go. There's no cut that happens. It just allows you to go back down to gate. So if it gets a little bit too high, it wants to keep the motor together, but you want to be able to continue the run. Problem is you might as well shut down if you're going from like 25 pounds down to 4 pounds like I would be doing. So it's like a soft cut basically. You're pretty much going to end the run, but you're still driving and everything. If you want it to flat out cut, then you set it to that. So a lot of people, what they'll do is they'll set, a revert to wastegate as a safety. And if you revert to wastegate and it's still going up or it's still holding, then so what you can do is say, all right, any boost pressure above 20 psi for more than a second and a half, I want you to revert to wastegate. And let's say something mechanical is actually going wrong. You can say, let's do this. So let's say 19 psi. Oops. We don't want to go above that. So you want it to revert to wastegate if it goes above 19 psi. Now, if it's above 19 psi still, after it's supposed to be at gate, let's say you give it a second and a half, and if it's still above that, that means obviously something physical has gone wrong. Let's say you lost your line to the bottom of the gate, and it's just sending, full boost, the solenoid stuck open, which is really rare. But let's say something mechanical happened to where it's still climbing in boost or still holding that boost, then you can tell the ECU to cut ignition. And that's all based off of the map sensor value. I like all the Spaceballs references. Makes me feel nice and old. Although that was I was a kid when it came out at least. What else we got here? I don't know. Let's see. Did I miss any questions or anything? Driver angle. Oh, okay. All right. What else can we do? Oh, here's some cool stuff. I think we went over this a little bit. So regardless of what wastegate type and solenoid configuration you're using, you can do your boost table. Right now it's in boost per time. So as soon as you let go of the trans brake, or as soon as you set it to, full throttle. You can set this trigger on a bunch of different things, but as soon as you activate your time, this is the table that it's going to be sampling across. So a lot of people will neck down that time. You don't need it for 15 seconds. Chances are you only need it for about, 5. Hopefully you're applying full boost before that as early as possible, not 0.3 seconds, Hayden. And, oops. But if you have some other sensors that you want to base boost off of, that would be nice. If you're calculating gear, or if you want to do it by RPM, which to me isn't all that useful, because you're going to be sweeping through the same RPM multiple times, but you're going to want the different amount of boost each time you sweep through that RPM. Now, boost per speed is pretty nice, especially if your speed input is a non-drive wheel speed. The problem with having it be the rear wheels is that if you start spinning, so let's do...
Do you need these hose fittings?
What hose fittings? Why?
I'm wondering something.
Oh, no, I don't. Let's see here. No, I'll just keep that. I can't hear you. Oh, gotcha. Okay. So if your boost curve is based off of rear wheel speed, when you start going through here, if you're hooked, this works just fine. If your car is dead hooked and there's no wheel slippage or anything like that. But remember, your rear wheels are basically an indication, or basically the same as RPM, just varying only because of what gear you're in. But it's attached to the motor, so it goes up with RPM. So if you're spinning, let's say we want this to be 25 pounds at max speed. Okay, so you obviously want to increase boost the faster that you go, but if you start spinning, the vehicle isn't going any faster because you're sitting there doing a burnout, but the ECU thinks that you're speeding up. So it's going to be increasing the amount of boost, which is only going to make the spin worse, and so that's just going to carry away. So it's nicer to have this be front wheel speed, because regardless of what the rear tires are doing, your vehicle is going a certain speed. So if you're sitting there doing a burnout, at least you're not going to be sampling a higher boost while you're doing that burnout. You're going to be just sitting there. So let's say you're not really accelerating very much. You're coming through this boost curve and you start spinning right about here. Your acceleration of your front wheels is going to start lowering. So you're not going to be creeping up into this table as fast. If you were to spin right here and you were using your rear wheel speed, this would just go way up, and so then it would just make it even worse. So it is nice to have some front wheel speed. If you have front and rear, then you can get clever and do some traction control stuff, but as far as boost control goes, I really like the front wheel speed option. I'll catch you on the next one. I have to be early. All right, Jeremy. Yeah, good to see you. Sorry you had to leave early. I thought of Spaceballs when I saw that Turbo LS Winnebago. Nice. Let's see. I think that's pretty much all I wanted to cover today. But let me know if you guys have any specific questions. Even if you think of it later, just comment it in the video. I just wanted to basically record something so that a couple of the guys that had some questions on kind of the different boost control methods, specifically the map pressure stuff and difference in solenoids and stuff like that. So that's pretty much all I wanted to cover. And yeah, go watch the new video if you haven't already. And if you have, go share it. Force one of your friends to watch it. And then force them to make somebody else watch it. See where this is going? I don't even know if I'm allowed to ask that, but hey, do that.
I don't think that's frowned upon, is it?
I don't know anymore. I think it is in Facebook. You can't say it in Facebook.
Really?
Yeah, you literally can't even tell people to share your stuff on Facebook. You're not supposed to say it. I have no idea why. Seems kind of strange.
You know, I heard Instagram was trying to get rid of their likes. Like they weren't
Oh,
allowed to
really?
show them anymore.
Huh. I don't want less. I don't want less options for like, liking or not liking. I want more options. Like, I want a confused face or a vomit face for a lot of pictures. Are there provisions for an ABS sensor on the front of the truck? No, not on my truck. So the way we're going to do that is I'm going to try to pick the signal up off the back of the wheel studs, basically. But the way that they're shaped, I don't think it's actually going to work out all that great. So what I might end up doing is basically gluing a magnet to each of those bolts and using that as a pickup. So it'll be a different sensor. Instead of using a magnetic sensor that's going to pick up on metal high points, it'll be a sensor that's going to pick up off of magnets. So I think that's probably the direction that we'll end up going with it, unless I grind down the faces of the bolts and making sure that it's consistent and having to be within like 30 to 40 thousandths. I don't think that's the way to go. So I'll probably, since I know all of those bolts are, identical size, they're just not the shape that I want them, I'll probably put a magnet on each of them, and that'll be my 6 pickup points. Watching it now, I'm in the Springs and was wondering where you guys meet up for the Jalisco trips. That is all the way down in Jalisco, Mexico. It's a hell of a drive. 17 and a half hours from here. It's pretty crazy, actually, that we made it back and forth in the weekend. Yeah, that is truth. I think SC 300 knuckles will fit the hard body, giving you ABS sensor. Really? Well, you know what? And actually, I think there were trucks, D21s that came with ABS. I just mean in my specific truck, I don't have that. So I was going to give that a whirl. But yeah, if I find out that they have an ABS version, like front knuckle setup, that would be nice. I would do that. Might make it a little bit nicer. More points would be nice. I think I can probably get away with 6 though. I don't need that fine a resolution. We're not getting crazy with it. Yeah, what else? What else we got before we go? We're going to be doing a different video than normal. I'm not going to tell them or nothing. We're going to do a little bit different video than we normally do coming up here soon. Probably in a couple of weeks. It's going to take a little while. It's going to do it in a couple of weeks. Yeah, well, I don't know. We might have to try it more than once. I'm not sure. It's not your normal documentary style or whatever. It's going to be kind of a fun video. Hopefully you guys will like. But
it's gonna be a makeup tutorial.
No, it's not gonna be a makeup tutorial.
I'm just kidding.
It'll still be automotive related, but I'm gonna do something a little bit different, have some fun with it. So I'll tell you guys more after we at least do some recording on it. I don't think we're gonna be able to just do it and post it up. There's gonna be a decent amount of trial and error and some editing that'll be necessary, but I'll give you guys a hint on the next video. It'll be fun.
A hint?
Yep, a hint.
Oh, you can give them the thing that I just bought. That could be the hint.
Yeah, we could do that. Tony's really excited about it. It was her idea.
Yeah.
We talked about it a while back. I thought it was a really good idea. We just didn't have the motivation, I guess, but we're going to do it now.
Didn't have the motivation.
Your face didn't have the motivation.
Because it's highly motivated.
What else? I think that's pretty much it. The only other thing that I would say... so I was going to go into the Terminator X stuff, but actually what I would do is just search for the Sloppy Mechanics video. I think Matt just did a video recently of him taking the map sensor value, the actual signal, and putting that into the dome pressure input, so that in Terminator X you can basically do this same thing. You're just going to be tricking the ECU into thinking that it has a dome pressure input, but really you're going to be using the map sensor value. So as far as the ECU is concerned on Terminator X, when you have the map sensor value going into the dome pressure value or input, it thinks you're targeting and showing dome pressure, but it's actually manifold pressure. So as long as you understand that difference, you can definitely make it work for you. And then that's the nice thing, is that we're sitting here on one of my friend's cars trying to figure out all of this crap about boost control. None of these values we were able, well, this stuff we were able to use, but the boost scramble, the trans brake stuff, any of the advanced tables, all of it is based on PSI. None of it does raw duty cycle. And that was the only way that we could control boost, is by creating an input and making it be in duty cycle numbers. And so we were wiring from that output that fluctuates duty cycle to the solenoid. So we had boost control and we had a table that we could do everything, but it was a pain in the ass because we couldn't do all of these other functions. We were having to do a new output and waste an actual output because we couldn't double up outputs, which was really annoying. So we had two tables. Let's say we wanted to have one activated when you're on the trans brake for boost builder, and have another one to activate when you release for boost control down the track. Well, we couldn't overlap those onto the same output. Terminator X doesn't let you do that. So that was a big wrench in the plans for boost control stuff. I figured we can do a bunch of different scenarios. As long as they were never enabled at the same time, we could put them on the same output so that one table is controlling duty cycle, and then when the other table is active, it disables the other one and controls the same solenoid. Well, we couldn't do it. So instead of having 3 different outputs dedicated to boost control, we said, screw it. I think we're going to give this whole map sensor thing a try. And so then, like the same day, Matt Apple actually did his video on it because he was talking about it for a while. He did the video on it. So if you're curious about that, if you have a Terminator X and you want to use map sensor value for boost control, give his video a watch, and then all of these things become usable. And you can create an advanced table for a progressing scramble button, and it works because you're doing target-based boost control. It's really nice. I think that's going to be the way we go on our friend Oscar's car. All right. Okay. Well, that's pretty much it for me. Just make sure you guys do me a huge favor. I'm assuming you already watched videos and everything, but share, comment on all the videos. It always helps to get a conversation going. And we'll see you on the next one, which is probably going to be some track racing for this weekend. Going to go help out Randy in the heap, and hopefully get him some personal bests. We're gonna switch over to a different power control method. We're going to do his on a timing retard setup in conjunction with some boost control instead of solely based on boost control. He just makes a little bit too much power per PSI to get that really fine control. So we're going to switch to timing control. Probably there might be some other cars too. I think Trent finally has his car ready to start testing, so we're going to see that. Awesome, his new Nova, and I think Oscar is probably going to test again too. We're putting nitrous on his car so that he can get through his converter in less than 10 seconds and get both of them ready for Outlaw Armageddon, which we may or may not go to. We got to figure that out. But anyways, thank you. I mean, I may do that. You can go if you want. Yeah, I guess we'll see you on the next one. Thanks for hanging out.